Hi and welcome back to another day in the lab. And well, you know, not every day is easy peasy as you would expect it, and as you would like to get your radios out after repair. So sometimes, you know, it is really annoying, since not all faults you get in are the same. So you really have different problems, different categories which you have to work on. And here this radio, an ICOM, which is on the bench right now, is really annoying, since it really has a problem which is intermittent. And the problem is, it is not only intermittent, so the fault itself shows very, very rare. So maybe 90 or even 95% the radio is working just fine, and then suddenly it won't transmit. So the transmitter just drops completely. And well, the problem is, I have seen it one time, I believe, that really the transmitter drops out, and then I thought, oh, just fine, now I can start probing and see where the problem is. And to be honest, in the moment I just wanted to start probing, transmitter is back working just fine, and you do not know what's really going on. And problems like this really can go on for days and days, because you really cannot find a problem as long it will not show up, because you really need to probe. I mean, alright, you have little tricks how you can try to get the transmitter drop once again, but even that does not really help. And you know, that is one of those radios where you try to heat up the radio, because that is often a problem that you know, if the radio drops out, it might be related to a thermal problem, or another problem is that you really need to cool it down. So that might be a problem as well. But this radio here does not really gives any indication, even if you heat it up, or if you just try to cool it down with freezer spray, or if you try to knock on the board, or you know, and that is really annoying, because the radio like this is really blocking your bench, right? I mean, yeah, you can do a second repair, so that is possible, but you still have running the radio on the bench or beneath, and hoping that the radio drops out to get into the problem. Well, so that is what I just wanted to talk about, and I just wanted to show you a little bit around. I just wanted to tell you a little bit about the categories you may face in your shop, in your lab, or whatever you want to call it, just to give you an idea that it is really not every day is not like the day before. So it is always different, and sometimes, as I already said, it could be really annoying, and you just have only one wish: come on, leave the lab and leave me alone. Well, in such cases you really need to try to gather informations at many as possible, and well, so you see here on the bench a hairdryer and a fan, and I try to really heat up the radio in a way that you really can't touch the surface, because you really try to drop down, the transmitter. And on the other hand, you try to cool it with a fan, and you try to get as much information as possible. So this today will not be really a repair video, as we simply are still here in the phase where we try to get the transmitter job to start probing, but that is not given. So you try to get all the informations around, and therefore I thought, let's talk a little bit about the different categories, I guess that it is how it is pronounced, of different faults you are facing. And I believe we have at least 3. So the first one is when the operator did something wrong. That means maybe there is a broken antenna cable, so that the transmitter burned out, or well, your SWR is bad, whatever, or you have a short maybe in your antenna system or whatever, so that it will have an impact to your radio. So that is a possibility. Or that some operators are playing the golden screwdriver, and they try to get the utmost out of the radio. So we often have seen, especially here, this ICOMs with 120 or 130 watt output power, and believe me, this radio is not able to handle such a high output power, since the design is not really able to heat this power, and that means that your radio is suffering. So I really had a lot of radios which has faulty final stages to a reason where somebody tried to really get the last watt out of the radio. So that is something which is known. So that is the first category. The second is if there is a design problem right from the factory, and maybe an example is this radio as well. So we know that, well, you have seen me working on this radio, and we very often had burned out pre-drivers, and I had to replace the pre-drivers, and over the time we have seen that the factory did a release on or a revision on the pre-amplification stage, and that is what we try to implement as far it is known, or we know that we have self oscillation issue with the radios, and then you try to do things to reduce the self oscillation, so that your pre-driver stage won't burn and really burn out. So we have seen really bad things. So that is to the design, and I have another example for that. That is from Yaesu, and you see this here. So that is a burnout VHF and 70 centimeter final stage, which is, as you can see here, completely burned out. That is related to two things. Maybe, or not maybe, I've seen, and that is known for this Yaesu. It is the, what is it? Let me think. Yeah, that is the Yaesu FT991. and the 991 is known for having the wrong BIOS setting for the finals, which very often ends up in, you know, blown. Let me turn it down. So maybe that is really annoying, hearing always the 1 kilohertz tone. So I haven't recognized it earlier. Sorry for that. So that is known as a final stage killer. So we very often had to align the BIOS current for these radios, especially when production started. But I've also seen the 991A, which had the wrong BIOS setting, and I really do not really understand that that is still a problem, since many of those radios burned finally completely out, and that is known that operators had trouble, especially in the beginning when the ramp up was from the FT991. So that is all on the design side, or we remember maybe the ribbon cable problem on the Yaesu FT-DX3000, where we had problems with the ribbon cable. So a lot of design problems, and that is what you get used to as longer the radio is on the market. So many times you see the same problem, which is related exactly to a design problem, even if the manufacturers never would give in and say, yeah, that is a design problem, so we have to take it back for a revise. They never do it. So we have seen it with the FT3, what is it, 300, the VHF UHF radio, where, you know, you have the overheated power amplifier. So you've seen it here on my bench as well. So you really have a bunch of problems like that. Well, and then you might come to the third category. You see there is a word I'm not able to pronounce, but I hope you know what I mean. So, and maybe we are really at the edge here with this radio. So now the ICOM IC-7000 is a couple of years old, and we are starting to get to the time where aging is a problem. So this fault could be related to an aging problem. So maybe that we have here some electrolytic capacitors which are dropping out. So that could be, I'm not sure. So I would say the last radios, and I've seen really a lot of this radios here, and they were normally related to, you know, design issues, or to, let me call it golden screwdriver problems. But now we are at the edge, and I believe this could be really, it could be a problem with, you know, aging. I mean, there is a bulletin out from ICOM telling about here our DDS circuit, which is responsible for the local oscillators, and if the signal of the local oscillator, so the level is dropping down, then that could cause a drop out of the transmitter, but even so on the receiver as well. But I've checked it, and that is fine. So just for so that you can see it. Yeah, that you can see it. So that is only an example on what you do. I mean, here we have the test point for the third LO, and let me show it on the scope. So that is a 438 kilohertz for the third LO, and it is just fine, as you can see it here, and the level, so that means the amplitude is just fine. And you need to check, of course, all the three LOs which are here. I believe this is the first LO, here's the second LO, right? So that is very important to do that. And I'm here for this fault. I'm also monitoring here over my adapter here. I'm monitoring the output signal here from the main board towards the final stage, or to the PA, better said, to see if the problem is caused by a dropout here of the main board, or is it more on the PA board. And that is what I'm doing here, so just that you can see that. So up there you can see my millivolt meter, which I can also use for dBm. And now when can we see it, when I press here the PTT, so you can see that we get here an output level, right? And that is, if you like, the needed output here from the main board. So we should have around minus 20 dBm, and you see that is working just fine. And we can, of course, test then the output level in general. And so you really try to get closer to the problem, and you're waiting that the transmitter is really dropping out, that you really can start your testing. And yeah, but that, as I already said, can really takes time. So you may have a radio like this really long on your bench, even if you put it aside to watch it while you are working on another problem. And yeah, that is then still not so easy. I don't know what your experience is, but when you have started troubleshooting another radio, then you try to concentrate really on that radio. You try to understand the problem, so you're going through all the stages, you do your testing, and then maybe suddenly your radio starts dropping out, and you think, oh my goodness, now I'm so deep here in my other repair, so that you know, this one have to wait. I need to get the other repair off from the bench. And yeah, you see, that is what I meant talking about yeah, annoying days in the lab. Right, so yeah, let me stop it here. I just wanted to tell you a little bit about that and my views on that. Maybe that one of you has already a solution here for this problem. Maybe one of you have seen it on your bench. I have to admit, especially this problem I have not seen. So that is really the first time. I mean, I've seen, as I already said here, the DDS dropout, where you change a little coil, that you get a little bit more output level, which will core the problem. So that is known, but especially this problem here is not known. So I have really to investigate it a little bit more in depth. But maybe you or a friend of yours have seen that problem, so maybe you have a tip. So let me know under the video. And yeah, so that are what you are facing in your everyday's shop lab life. and maybe that was a little bit interesting as well. So that's it for today. Thanks for watching, and hope to catch you again. Bye, my friends.